Welcome back, math friends. Today we are talking about rational numbers. We are in topic 7 and block 1. Now, rational numbers, before we get into dealing with rational numbers, because before we're done with this topic, topic 7, you're going to be able to add, subtract, multiply, and divide all sorts of rational numbers. But let's talk about what numbers they are. To understand rational numbers, we have to start with the smaller subgroups. First of all, let's talk about natural numbers. So I'm going to make a box. Draw a box in your notes in the top left-hand corner, and we're going to call this the natural numbers box. All numbers in this box are natural numbers. Okay, and the natural numbers we have talked about before, but maybe you forgot. Those are your counting numbers, the numbers that you first started to learn, starting with the number 1 and 2 and 3 and 4 and 5 and 6 and so on for forever. All those numbers that you could count on if you had enough fingers and toes, and your friends' fingers and toes, and so on. Okay? Those are the natural numbers. Now let's talk about the next grouping of numbers are the whole numbers. And so I'm going to expand, make my box just a little bit bigger, and I'm going to talk about the whole numbers. Whole numbers. Now the whole numbers are basically, they are all the natural numbers, because you can see the natural numbers are inside the box of whole numbers. But the whole numbers, the only thing that makes them different from the natural numbers is we have the number 0. So it starts at 0 and 1 and 2 and 3 and 4 and so on, just like the natural numbers, only the whole numbers start with 0. That's the only difference between whole numbers and natural numbers, is the addition of 0 to that set. Okay, now we're going to make a new box, just slightly larger than the whole numbers box. Now notice that the natural numbers and the whole numbers are inside this box because they are part of this group. And this is the group of integers. Okay, now the integers are everything you see already. They are the natural numbers, the whole numbers, but now we are also going to add their opposites. So where we had 0, we have, and we have 1 and 2 and 3 and 4 and 5 and 6 and so on. Well, then we also have negative, we have negative 1, negative 2, negative 3, negative 4, negative 5, and so on that direction too, right? So those are all our integers. So we have whole numbers, natural numbers, integers, and so now, once we get past that, once we get past the natural numbers and the whole numbers and the integers, then we get into a really big group, a huge group of numbers, and this super large group is called the rational numbers. Okay, so rational numbers. Now, the rational numbers include the natural numbers. The natural numbers are in the box of rational numbers. Whole numbers are inside the box of rational numbers. Integers are part of that. But rational numbers also include things like the stuff that's in between the integers and the whole numbers and the natural numbers. Stuff like 1/2, 1/4, negative 1/3, negative 2/5. How about negative 3 and 3/4? So it includes fractions. And it also includes decimals like 2.5, 3.7. How about 0.333 repeating? Those are also included in the rational numbers. So you can have repeating decimals like that one. And that's a repeating decimal where it just keeps going and going and going and going. Or you can have this type of decimal, which is called a well, for lack of a better term, we'll call it a non-repeating decimal because it doesn't keep repeating. And it doesn't, now decimals don't have to be, when they repeat, that doesn't have to be the same number. It could also be like 1.313131 and so on. So those are all types of rational numbers. And the reason that they're called rational numbers is because they can be written as a fraction. All natural numbers could be written as a fraction. For example, the number 2. The 2 can be written as a fraction by just putting a 1 under it, right? And an integer like -3. -3 can be written as a fraction because it would be -3 over 1. Okay, so that can be written as a fraction. So all of your natural numbers, whole numbers, and integers can be written as fractions simply by putting a 1 under them. But all these other rational numbers that are already fractions and decimals, they can all be written as fractions, and that's what makes them rational numbers. Okay? So this whole unit is all about what we can do with rational numbers. Okay, so let's get on to something else entirely. Are you ready? I hope so. Just a sec. Now that you've copied down all that information about rational numbers and the world of numbers that we have here, let's try to do some operations that involve rational numbers. So in the notes that you took the other day, you should have learned how to convert mixed numbers to improper fractions, and you also should have learned how to add, subtract, multiply, and divide different types of fractions. So these are all things you should know how to do. So let's start off with a couple of these just to get us started, and we'll go from there. First of all, let's go with something where we're adding a couple of fractions together, mixed numbers together. So let's start off with 2 3/4 plus 6 1/6. Now, there's nothing super hard about this, but there are some things we have to do first. We have to convert these mixed numbers to improper fractions. So let's do that. 2 3/4 plus 6 1/6. First of all, convert our fractions, our mixed numbers, to improper fractions. Now remember, in order to convert a mixed number to a fraction, you have to first multiply the whole number, the 2 in this case, times the 4, and 2 times 4 is 8, and then I'm going to add the numerator, which is 3. So we're going to 2 times 4 is 8, plus 3 is 11, so that is 11/4. So 2 3/4 is the same as 11/4. And we're going to do the same thing with 6 1/6. Multiply the whole number times the denominator. 6 times 6 is 36, plus 1 is 37. 37, and we keep the denominator the same, 37/6. All right, now we have two improper fractions, and we can add those together just as soon as we do one other thing. You'll notice that their denominators are not the same. We can't add them if they don't have the same denominator, so we've got to make them have the same denominator. So we have to find what is going to be the least common denominator. So we have to find the LCD, the least common denominator. And to find that, we have to find the least common multiple of the two denominators. We have to find the smallest number that 4 and 6 will both go into. So it's going to be, and I always look to see, first of all, is it 4 or is it 6? Is it one of those? No, because 4 won't go into 6. 6 will, but 4 won't, so we can't. We have to find the smallest number they will both go into. And if I search around long enough, I will find that that number is 12. 12 is the smallest number that they will both go into evenly. 4 goes into 12 and 6 goes into 12 evenly. So now we can convert these fractions into fractions that have a common denominator. And in order to do that, I'm going to have to ask myself, well, self, how many times? 4 times what equals 12? Well, that would be 4 times 3. So 4 times 3 is 12. I have to multiply the numerator by that same amount. So 11 times 3 is 33. Okay. And now I've converted 11/4 to 33/12. It's the same fraction, it's just smaller pieces. And I have to do the same thing with the 6. 6 times 2 equals 12. But what's 37 times 2? Oh gosh, that's 74. So now I have 33/12 plus 74/12. And now, because the denominators are the same, I can just add them. Now remember, the denominator is going to stay the same, and I'm going to add the numerators. So 33 plus 74. Well, 3 plus 4 is 7. I don't have to regroup anything, and 3 plus 7 is 10. 107/12. Well, that's pretty awesome. Now, if I wanted to, I could convert that into a mixed number, but this is good. This is excellent. But if I want to, I can convert this to a mixed number. So 12 goes into 107. How many times? Well, I believe that would be 8. 8 times. 12 goes into 107 8 times. 12 times 8 is 96. And so I would have 11 left over. And I keep my denominator the same. So either one of these is perfectly fine. 107/12 or 8 and 11/12. So adding mixed numbers. First of all, convert the mixed numbers to improper fractions. If the fractions don't have common denominators, get a common denominator so they have the same denominator. And then add the numerators. And if necessary, convert an improper fraction to a mixed number. Okay, so that's adding fractions. Now let's try subtracting. Okay, so we're going to try subtracting one now. Yeah, scroll down here. And let's go with 14. Whoa, that's not what I wanted. Let's go with 14. Let's make that a little bit thicker line. Make life a little easier. 14 minus 2 3/5. Okay. Now, first things first. I am dealing with a whole number and a mixed number. I want to change my whole number, first of all, to a fraction. And that's super easy, remember? Just put a 1 under it. But now I have to convert my mixed number to an improper fraction because I can't leave it just the way it is. So I am going to multiply my whole number times my 5 times the denominator. 2 times 5 is 10 plus the 3 is 13. I keep the denominator the same, 13/5. And now I have 14/1 minus 13/5. You can see they do not have a common denominator, so they need one. Now this should be an easy one to find because the smallest number that 1 and 5 will both go into is 5. 1 goes into 5, 5 goes into 5. So now I can keep 13/5 as 13/5. That doesn't have to change, but I have to multiply 1 times 5 to make 5. I multiply 14 times 5, and that happens to be 70. So now I have 70/5 minus 13/5. Now they have a common denominator. All I have to do is subtract the numerators. So 70 minus 13 is 57. And I keep the denominator the same, 57/5. And that is perfectly fine. That's a good one. It's an improper fraction, but that's okay. But I can also change it into sorry about that, I can change that into a mixed number. I'm going to divide 57 by 5. 57 divided by 5. 5 goes into 5 one time, that's 5. Subtract, I get 0. Bring down the 7. 5 goes into 7 one time, that's 5. 7 minus 5 is 2. I have a remainder of 2 now that I'm done. 11 and 2/5. I keep my denominator the same. 11 and 2/5. That is also good. All right, there you go. Adding a whole number and a mixed number. It's using all our good fraction skills. Now, let's take a look at multiplying a couple of mixed numbers to get us going here. So let's do, well, let's see here. You know what? Let's get away from the mixed numbers for a bit. We're going to just do a fraction. 12/25 times 5/6. Okay? Now, we can just multiply, because we're dealing with multiplication of fractions. The great thing about multiplying fractions is we can just multiply straight across. That's the coolest thing about fractions, is we just multiply straight across. Now, 12 times 5 is 60. And 25 times 6, you know, if you have to use a calculator to do that, that's okay. 25 times 6 is 150. Now, this is a great thing here because look at this. They both end in a 0, so we can simplify this by dividing each of them by 10, first of all. If we divide both of them by 10, basically we just cross out that 0 and we get 6/15. But we should also simplify these fractions by, they can both be divided by another common factor, which happens to be 3. So let's divide by 3, both of them. 3 goes into 6 and 15. 6 divided by 3 is 2. 15 divided by 3 is 5. So we're all done. 2/5 is our answer. If you take 12/25 and multiply it by 5/6, what you get is 2/5. Okay, remember, multiply fractions straight across. Always simplify by common factors to get the most simplified answer possible. All right, we have one more. This one's division. So we are going to take a look at 2 1/10 divided by 2 4/5. Okay? Now, we can't work with these the way they are, so we need to convert them to improper fractions. Convert all mixed numbers to improper fractions before you do anything with them. It's easier that way. So, multiply the whole number times the denominator. 2 times 10 is 20, plus 1 is 21, and keep the denominator. Divided by, let's see, whole number 2 times denominator 5. 2 times 5 is 10, plus 4 is 14. 14, keep the denominator, 14/5. Now, we can't just divide straight across. It's not the same as multiplication. But remember that division, I've told you this before, division is multiplying by the reciprocal. So what that means is we are going to keep the first number exactly the same. The first fraction stays the same. But instead of division, we are multiplying. And we're going to multiply by the reciprocal of 14/5. And if you remember, the reciprocal of a number, when it's a fraction, is you just flip the fraction, because the reciprocal is whatever you multiply that number by to make 1. And 14/5 times 5/14 is 1. Anyway, now that we have it set up as we are multiplying by the reciprocal, keep the first number the same, multiply by the reciprocal of the second number, now we can multiply straight across. And if you need to use a calculator, don't hesitate. Okay, 21 times 5 is 105. And 10 times 14 is 140. Now I recognize that both of these can be simplified. The numerator and the denominator can be divided by a common factor of 5 for sure. Okay, now so that would give us 21 here, and 140 divided by 5, and I know it's divisible by 5 because it ends in a 0, is 28. 21 over 28. And now, because I know my math facts, I recognize that these both have another common factor of 7. 7 goes into 21 and 28. 21 divided by 7 is 3, and 28 divided by 7 is 4. So 3/4 is what you get when you divide this 2 1/10 by 2 4/5. You get 3/4. Okay, well, that's all I've got for you today. Kind of an introduction into doing some adding, subtracting, multiplying, dividing with mixed numbers and fractions and stuff. Have a great day. Don't forget to be awesome, and I will see you next time.